In this repair video, we're going to be working on an iPad 9.7 inch, the 2017 model. It came in for no power. We already disconnected the screen and the battery. We do not want to expose the battery to heat from our hot air station. And since the customer already tried to replace the battery, it was easy to take out. So I put the battery on the side here. And now the first thing I want to do is use this $5 TriStar tester to see if we have a problem with the charging port or with the TriStar charging chip on the board. And we use this TriStar board on the 12.9 iPad that we got last week. So today we're going to be using it on this 9.7 inch 2017 model. I think the model on this one is the A1823. Yeah, A1823. Right now what we're going to do is we're going to use the multimeter in diode mode. We're going to put the red probe on number 8 and the black probe on the rest of the pins and see what readings we get. Now to use that board, you will have to know what the readings are for this specific tablet. Right now, I do not know what the readings are for this specific tablet, but I just want to see if there's anything obvious with the way the testing will go using this board. I do have a TriStar tester that we can plug in, but I'm trying to do it as manual as possible because a lot of people out there cannot afford to buy a TriStar tester. So let's see if we can figure it out using this board without me having any prior knowledge of what the readings should be on this tablet. Red probe on pin number 8, meter in diode mode. Look at this. It's reading a short. What about this one? It's reading a short. 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 So everything is shorting to ground. Every single thing is shorting to ground except for pin number 1. Everything is shorting to ground. So what's the problem? Is it the charging Flux cable that's causing the short, or is it the TriStar charging chip that is causing the problem? If I want to take an educated guess, I would say it's the TriStar chip because I do not see how the Flux cable is going to short out. It's soldered onto about maybe 63 pins or 65 pins. I do not know how many pins it's soldered onto, but I do not see how that cable is going to short out. It's possible, but very unlikely. Right now, I think our problem is the TriStar chip. So I'm going to start by soldering a new chip. If that does not fix the problem, then we're going to solder a new Flux cable. But it's hard to tell from a TriStar tester or from the TriStar board if we're going to have a problem with the Flux cable or with the TriStar chip. So let's go ahead and replace the TriStar chip and see if that will fix our problem. And the TriStar chip is right over here. It's a good thing the tablet is not the iPad Air because it would have been a lot more difficult working on the iPad Air TriStar chip. The chip is protected with an overcoat. This one is not, just like all other tablets. What I want to do is cover up the FEC connectors on top. Look at how close FEC connectors are to that chip. Very, very close. I mean, we are looking under a microscope, but if you look at this with your naked eye, it's right next to it. Right next to it. And right now, I think I'm out of the aluminum tape. So I'm not going to be able to use aluminum tape to cover up the FEC connector. But I will use Captain tape. That's the only thing I have right now. I like aluminum better than Captain, but that's what I have right now. And let's desolder the chip. Pin number 1, as you see, is on the top left, so I'm gonna mark this area here so we do not forget, or I can go back to the video in case I forgot. So I'm gonna blow heat away from the connector. I'm pointing heat that way. And it's out. But we have to fix this cap right there. Very nice. We need to clean unleaded solder and wick off those solder balls. Get rid of the glare. And let's do it. Very nice. working dangerously close to those components. Any wrong move and those components are gonna have solder on them, and then you have to take the solder off, and then it's gonna take more time to work on this board, and everything else follows. So right now we are good. Where is our brush? Apply flux, and we're gonna use our hot tweezers and a piece of wick, premium wick, to desolder the balls of the pads. Very nice. We did a very beautiful job desoldering those solder balls off the pads. And now what I want to do before we solder the new chip is to test. I'm going to use that same board to test to see if we still have a short on those pads. Maybe I'll do it under this camera here. We're going to have red probe on pin number 8 and black probe, and we still have a short. Wow, we still have a short. So the problem is not the TriStar chip. We did all that work for nothing, but we had no way of knowing if the problem was the TriStar chip or the problem is the Flux cable. But that's how we learn. The next time we get a tablet where we're gonna read a short on all the pins here, I'm gonna start with the Flux cable and not the chip. That's how we learn. Let's go ahead and replace the chip. And we'll move on to soldering a new Flux cable. What can you do? Maybe we had a bad TriStar chip also, who knows? We're gonna change it anyway. Let's grab a TriStar chip. And of course you can find those chips on our website. They are sold in batches of 5. Along with most of the tools that we use here. From flux to tweezers to the brush, gloves, everything. Okay, so we're gonna grab it like this, apply heat for a few seconds until that chip makes a connection, and that Captain tape is in the way. Great. Let's see if the chip made a connection, and yes, it did. And now we're gonna reflow that chip down in place, apply more heat. What's wrong with this tape? That's why I like aluminum tape. It does not move. Captain tape can shift components under when heat is applied to it, and I never use it. I have it, but I prefer aluminum tape. Okay, job is done, but I do not like the way the capacitor is going sideways. I like it to be perfect, just like that. What I'm going to do is ask Big Boss to remove the board of the housing, and I'll be back. Big Boss just removed the board, and look at this. Customer already attempted to replace the charging flex cable. If I knew that the customer attempted to replace the charging flex cable, I would have started with the flex cable. But I did not think that there would be any short on the flex cable, because these cables do not short. It's usually the chip that shorts. But it looks like the customer may have shorted out the pads while attempting to solder this flex cable, and that explains why we have a short on every point on that tester. I wonder what we're gonna find when we look at this under the microscope. I just wonder what we're gonna find. That explains why we have that short. I was almost 100% sure the problem is the chip, but since we have a prior repair attempt on this cable, then it's most definitely a problem with this cable. Look at this. Look at this. Number one, the cable is not aligned. We have a short. Big mess here. Yeah, that's a mess. That's a mess. I do not know how the pads under are gonna look like. Let's hope for the best. The guy who brought this in, he came to the shop here, very nice guy, and he brought in two tablets, a 12.9 and this one here. We already fixed the 12.9, no touch issue, and now we are working on this. Let's apply heat and remove this cable, and hopefully we will have some pads under that cable. I'm just hoping. We have missing pads. Just like I thought, we have missing pads. Not one, not two, but more. I mean, if that customer just told me that he did attempt to replace the flex cable, it would have made my job easier and wasted less time. I quoted the customer two prices. I quoted him a price if it's either one, the chip or the flex, or a price if we have to do both. Since we did both, the customer is going to be charged the higher price. We have a line going from here to here. That's what I see. And this one, based on what I can see, this is nothing but a ground pad. So this pad is the same as this and the same as this. We're not going to run any wires here, and we're going to leave it as is. This pad, however, is going somewhere. I do not know where this pad is going to. And what is this? I do not know what this is, this black stuff. Oh, wait a minute, wait a minute. I think the pads may still be here. I don't know, is that glue? What's this? I do not know what this is. I think this is a piece of the flex cable. I think that's what this is. It's part of the flex cable. We do not have any missing pads. Look at that. That's only part of the flex cable. Okay, great. I feel much better. Because I pulled my sleeves up and ready to do some heavy work. But it looks like we're gonna have to run one jumper wire. And we can probably run that jumper wire from over the cable and not from under. But we have to find out where this trace is going. Okay, meter in continuity mode. I want to check that what we scratched is actually the trace and not the under layer, which may be ground. And that's the right trace. Okay, so now we're gonna check. We're gonna have to remove this tape and just check under it and see what point under this tape connects with that pad. And I'll run the jumper wire from over the cable and not from under. Let's see which point connects with this one. Right there, right there. So right on top, a wire from here to here. Great. So I'm gonna clean the pads. I'm gonna switch over to a Barlow lens so we can see the whole connector and align this flex cable properly. Now that we put the Barlow lens on, now we can raise out the microscope more. The Barlow lens will allow us to see more area on the board. Look at this, now we can see that much. Before we could barely see from end to end. Now we can see the whole thing. And now we can properly align this flex cable here. Okay, so we're gonna apply a big solder blob on the soldering iron tip right here and just go like this. And that's the job that you get when you use good flux. So we have 1, 2, 3, 4. This is gonna have to connect with this. So what we need to do now is run a wire from here onto the 4th pad of the flex cable. Awesome. We did an amazing job. Amazing job. And I just want to put the meter in continuity mode and test from pad number 4 to this point here. Very nice. We do not need to mask that wire. Nothing is gonna touch it. But what I can do is I can put Captain tape over, just like that. Let's test. We're gonna use that same board. We're gonna test from pin number 8 to here. And now we are not getting a short, but also we are not getting any reading. OL, OL, OL. No reading on none of the pins. Wow. Nothing. Why? Why no reading anywhere? We're gonna check on the soldering one more time and go over it and see what's going on. I mean, everything looks good. I'm gonna go over the soldering one more time. We're gonna do this pin by pin. And let's do the other half. Okay, I mean, soldering cannot get any better than this. So there's no reason why it should not work. and the cable is perfectly aligned, as you see. There's no reason why this would not work. Now it's working. Okay. 0.755, 755, 753, 755. And I'm gonna use my TriStar tester just to confirm. And it's a pass. Okay. See how the board was able to first tell us that there was a short, and then the board did not give any readings because the connector was not soldered on properly, and now it gave a reading of 0.755. And now we confirmed that the Flux cable and TriStar chip that we soldered are functioning properly because the meter gave us a pass. I'm gonna let Big Boss reassemble the board, and I'll be back in a few minutes to finish off this video. Big Boss reassembled the board and the tablet is on. It's working. I want to test the charging. And charging on the tablet is 0.98 amps. Awesome. That's perfect. So everything is good. We're going to call the customer to come and pick up. And I think we did an amazing job. In this repair video, we're going to be working on an iPad 5th. In this video, we're going to be working on an iPad 9.7. This is the 2000. Right now, battery brought this in. And it's a good thing this tablet is not a MacBook